Imagine a fly buzzing around your room. You spot it, you track it, and you swat at it with everything you've got. But you already know exactly what happens next. The fly dodges, effortlessly escaping your hand again and again. In those moments, it feels almost supernatural, as if the insect can somehow predict the future. But what if the reality behind this everyday frustration is actually much stranger than science fiction? Let me ask you something. What if that fly isn't predicting your movements at all, but is simply experiencing time at a completely different speed than you are? To that tiny creature, your hand might be cutting through the air in slow motion. This raises a bizarre, mind-bending possibility about the nature of life. What if time doesn't feel the same for every living thing? What if a single second for a fly stretches out much longer than it does for a human? The clock on the wall measures physical time, but how quickly does a brain experience reality itself? We naturally assume that every creature experiences the present moment exactly the same way we do. But this anthropocentric view is fundamentally incomplete. Take your dog, for instance. When you watch a dog sniff the grass, you probably think they just have a stronger sense of smell than humans. But the truth is far more profound. Your dog isn't just smelling the world. They are smelling time itself. A scent trail left on a fire hydrant isn't just a chemical signature. It is a temporal record. By analyzing the decay and intensity of microscopic odor molecules, a dog can tell exactly who was there, which direction they went, and how long ago they passed by. They are reading the past and predicting the immediate future through their noses, shattering our rigid concept of a shared, uniform reality. To grasp how this works, we must look at a concept known as temporal resolution. Think of reality as a movie. A film isn't a continuous stream of motion. It is a rapid sequence of still images, traditionally 24 frames per second, that your brain stitches together. If the frames drop too low, the illusion breaks. Every animal species possesses its own biological frame rate, a specific limit at which the brain samples and processes visual information from the world. Scientists measure this using the critical flicker fusion threshold. If a light flashes fast enough, the human eye eventually perceives it as a steady, continuous beam, usually around 60 flashes per second. But for other creatures, that same flashing light looks like a slow, stuttering strobe. They are effectively operating at a much higher refresh rate, capturing far more slices of reality within the exact same physical second. This biological frame rate explains why some animals seem to inhabit an entirely different tempo of life. Consider the famous studies by Dmitry Belyaev on silver foxes, which prove that breeding for tameness rapidly alters not just behavior, but physical traits and hormonal cycles, effectively accelerating evolutionary time. In the realm of cognitive rhythm, we see creatures like Snowball, the dancing parrot, who stunned researchers by demonstrating that non-human animals can spontaneously perceive and synchronize their body movements to a musical beat. This requires an incredibly precise internal clock, a rapid mental processing of acoustic time that most species simply do not possess. Whether observing the genetic shifts in Belyaev's foxes or the rhythmic precision of Snowball, the evidence is clear. The speed at which animals process, adapt to, and move through time is finely tuned by evolution to fit their survival. Yet, as deeply as we probe into these temporal mechanics, we inevitably hit a wall built by the limits of modern science. We can accurately measure a creature's reaction times, calculate its metabolic rate, and track the firing of its neurons, but we cannot truly step inside another mind. We can never genuinely experience how a hummingbird perceives a blooming flower, or how a tortoise registers a passing decade. Furthermore, time perception isn't merely a byproduct of body size or metabolism. It is deeply tied to cognitive novelty. Human adults often feel that time accelerates as they age simply because life becomes more repetitive, whereas children, flooded with constant new experiences, perceive a much slower, richer flow of time. Do animals, navigating an ever-changing wild world, experience a perpetual youth of time? Ultimately, we are left looking through a glass darkly, guessing at a reality we may never truly inhabit. This realization brings us to a profound truth about our place in nature. We like to think of ourselves as separate from the animal kingdom. but we all occupy the exact same physical universe, ticking away to the same universal clock. Yet, the science of time perception reminds us that reality is entirely subjective. There is no single, master tempo to life. Instead, every species inhabits its own unique bubble of the present, a beautifully tailored rhythm of existence. The next time you fail to swat a fly, or the next time your dog stops to obsessively sniff a blade of grass, remember that they aren't just reacting faster or smelling better than you. They are simply living through more of the present moment, experiencing a slice of reality that is completely hidden from your eyes. Perhaps the ultimate beauty of evolution is not that it created different creatures to share our world, but that it designed entirely different worlds of time for each of them to discover.